Hello everybody, this is GenJift here, and we're back with another installment of using immersive engineering to build a computer in Minecraft, and we're a bit closer to it. So I sat down and realized I needed a lot of materials in terms of vacuum tubes, the circuit plates for the logic circuits, and just in terms of logic units as well. And I figured I'd have to make a manufacturing plant to make all this material, to make the computer, because there's going to be a lot of material needed. So, in doing that, I've decided to try to expand on all the stuff and using the logic units and circuits to control all the manufacturing, so we can actually gain more experience to build the computer itself using all these components. And we have. So, this is the plate and wire manufacturing facility. There's going to be a lot more going off in that direction, as I have completely blown up the room of all the truth tables because I needed room to make all the manufacturing. The factory is expanding to meet the needs of the ever-expanding factory. So, but now, we have our first working clock, because that's something I needed to develop anyway, so I used this opportunity to develop a functioning clock in order to meter out how much material comes out from the ME export buses into these chests in order to go into the extracting conveyor belts, because if I don't, it does this. And it's a giant gobbledygook of a mess. Computer did not like that. Oh, I should have really grabbed the stuff out of the chest first. That was kind of dumb. So yeah, I need to meter this so that the presses do not get completely overwhelmed by the stuff coming into them. So that's what this system here does. There's a stone missing somewhere. Nope. It's in there. 61. So yeah. So we're going to go turn the clock on, and we'll see the first problem I had to sort out. It is a mess. The clock signal is an absolute crap show. And I need something steadier than this to use for the computer. So I've developed this like small counter thing. It's got a couple logic circuits up there, and it's got a few logic circuits down here. And in a moment we'll show you what that does. Okay, so here's the diagram drawn out on a piece of paper that I have then scanned into the computer, and I'm now using Paint to explain and walk through how this works. So, there's my mouse. Okay, so we have the XOR. We're going to grab a pen. We're going to make the size bigger. And what this does is based off of a pulse from the white signal, which is pulled off of one of the torches. It's the old... It's an old Minecraft clock using these torches. That's how it's set up. And each one of them is, this signal is pulling off of each torch, and one of the signals goes into the white line for the immersive engineering, and it comes in here. And the first pulse will use green. So what this is, one pulse from the white in the clock turns this memory circuit on. The next pulse turns it off. So the first pulse comes in, goes to the XOR, which is then converted into registry 0, and registry 0 is then converted into orange. This travels down. All that happens in this right here. White to register 0, orange is set by register 0. Then this travels down to the next box, goes into the next logic unit, is converted to register 0, goes into this OR, which then comes down to register 1, and the register 1 gets fed back into the OR. Yeah, I could actually have skipped that entirely because it doesn't make any difference, but I did that because the way the system runs, it doesn't make a lick of difference whatsoever if I do that or not, and that's converted into magenta. Magenta goes through one of these insulation block things and is converted into a black signal, which is then fed over into the logic blocks over here, the logic units over here. And we'll show you what it does over here in a moment. So then this magenta goes back up and into the unit above it. And that's the first pulse. So we change the color of this, and what happens is the next time this pulses, now we have two signals going to the exclusive OR gate, which means this entire thing is now stopped. So now there's no more orange, there's no more registry 0, there's no more registry 1, there's no more magenta. And then there's no more black signal. And it stays that way until the next time white pulses back in. So the first pulse from white turns this memory, puts a bit into memory basically. And then the next pulse clears that bit from memory and it stops sending the signal into the rest of the system. So we kind of have a, it's not really a well, it is a CPU clock, but it's not, we haven't quite made a CPU yet, we've just made a clock. And it works for the purposes here. I need to modify this some more to get it to actually work for further purposes, but this is a start and it actually does work. And I'll show you what it does. So it cleans up this absolute mess of a signal. And it allows this to do its job. So what this does over here, let me move, oh, no, Control C. So what this does over here is also fairly straightforward. On this board I have a bunch of status lights which are fed into these redstone wire connectors, and this is fed into here. So we've got electrum in the first row, copper in the second, aluminum in the third, and steel in the fourth, and the top one is for wire and the bottom one is for plate. So if I go back over here, I take out copper. I take out like all these copper plates. You can see now we have the indicator that we need copper plate. That signal is passed into this, which then starts spitting out copper at a metered rate. And now you can see the clock working. It's a bit clunky looking right now. It's a smoother thing than that. It's a little bit smoother. And it meters out the copper very nicely. And as you can tell, since we need copper plate, all the copper is being shunted through the metal press for plates. And if I put all the copper plate back in, and then take all the wires out, it starts doing it again and redirects all the copper ingots over to the wire stamp. Exactly like that. Now I'm going to toss all the wires back in, and it'll shut off the copper from coming back into the system. And then there's a little bit of we get extra wire and extra plates here and there. It's not perfect, but it's good enough for this, and if I get some extra plates once in a while, whoop-de-doo. So now for the logic for that part. So what's happening here is the black signal is coming into the box and converted to registry 4, which then goes to the AND in here. And say we need wire in the copper that's orange. The orange signal comes in, goes into this OR, which is converted to registry 1, and then goes into here. And that goes out as cyan, and if we look in the back wall here, cyan is this chest here, and it's connected to this export bus, which exports copper. Now it'll only export copper when both registry 1 and registry 4 are active. That is the only time this signal goes through to spit out copper. And that is what the clock is for over here. That meters out the production of copper into the factory. This down here tells the system what is needed. It goes into this ore, which then goes to register 0, which is then converted into brown, and it comes back out for plates, or it comes back out for wire. And that is how that system works. And it works out very nicely. So we'll go to, let's go to aluminum. We'll take all the aluminum plate out, and then we can see it in action with aluminum. Because the aluminum's wired up the same way. And now, because immersive engineering doesn't actually have convenient filtration belts, this is what I ended up doing, is that the signal basically shuts off or turns on and determines whether these dropping conveyor belts are active or not. And I had to set up as the inverse, so technically when plate is active, I have to turn on the wiring, I have to turn the dropper conveyor belt here on, then it turns it off, and yeah, confusion. It was interesting to figure that out. It's inverted. So yeah, that makes a nice system that produces my wiring on demand as the factory needs it. And also makes all the plates on demand as the factory needs it. Based off the levels that are in the what is this? ME drive computer system thing with all the ME controllers. And the entire system put together looks like this. Where'd it go? That's it there? Okay. Pull this over. Yeah. And this is what the entire wiring diagram for the entire system that is manufacturing all the wire and plates for me now automatically looks like. The entire wiring diagram with all the gates and all their respective boxes all set up. Now, as you can tell, I have set this up as well with 3 logic units connected, so I can change if I want to reset how all this is and move this elsewhere. I don't actually have to deconstruct this. I can just reuse it again. I don't think I'll ever need 4 or 3 of these things, but it's there. And then we have this entire diagram set up right here that explains how the entire thing works. And it took me a long time to figure this out, how to get it to work correctly, but it works now. And it's really convenient, and I'm going to expand on this to expand the factory to use it for other things, such as making the logic units themselves, all the plates, the back plates, vacuum tubes, and I'll probably mass manufacture the circuits for OR and NAND XOR using this system here, or something similar to this. And it's been interesting so far, to say the least. I just wish I was doing it faster, which is entirely my own fault for not sitting down and actually doing this faster. But don't forget to like, share, and subscribe. I hope this goes, at least if you're not, say, making a full computer, I hope this tells you how you can use these logic units, because there really isn't anyone talking about the logic units in immersive engineering, and the things that you can do with them to control factories. So, don't forget to like, share, and subscribe. We'll see you next time. Have a good day. Hello, I hope you've enjoyed the video. Don't forget to like, share, and subscribe, and hit the bell icon and all that wonderful fun stuff, because subscribing to YouTube is no longer enough. Hit all the things. Hit the like button. Like the comments. Comment multiple times. And don't forget to share. But subscribe and hit the bell. See you next time. Bye. I think our tank exploded. Whee! There it goes.
What, the plane or our tank?
Well, there's a tank flying through the sky.